In my garage, I took some PVC pipe and made some tools that we use in the oil and gas industry to try to illustrate how we drill and complete wells. When we drill oil and gas wells, two of the primary responsibilities of our industry and drilling engineers is protection of people and the environment. The way we do this, or part of the way that we do this, is we drill a series of holes in the ground, and after we drill a hole in the ground, we run pipe, which just illustrates that casing that might be run in some hole section, and it's cemented. What I'm going to describe to you now is the very last string of casing that we might run in a well bore that has oil and gas hydrocarbon bearing zones. So I'd say the main responsibility that we have is protection of people and the environment. The way we do that is we drill a hole that's larger than this casing size, that this casing will fit into the well bore, and cement comes through the casing. It's real heavy cement. It goes through the bottom of the casing, and this is, I described a down jet float shoe that has holes in the side of it and in the bottom of it. That heavy cement will go down through the casing and come up around the outside of this casing between the bore hole and this casing wall. The way we keep that cement in place is we have a ball seat that's run in the float shoe or float collar, and that ball, we can pump the cement around that ball, but after we finish pumping the cement, that ball will go up and seat on a sub to prevent backflow, to prevent that cement that's heavy on the backside from going back inside our casing. So we end up with a casing that is cemented with a sheath of cement between the OD of this casing wall and the borehole, which is larger than this casing. It would be run without these holes in the side of the casing. When we run the casing, there are no holes in this casing. And then after we have run and cemented this casing, during the completion procedure, we will perforate this casing with some holes that go through the wall of this casing to the hydrocarbon bearing zone. And then we have a series of, we produce this well up through the casing and tubing that's run all the way to the top. And there's a series of valves on the top of this well bore which controls the flow, any flow, and that is called a Christmas tree. Quite often, this hydrocarbon bearing zone that we're producing from has a tendency to make sand. It may not be very competent. So in order to keep the formation sand from producing into the well bore and coming to the surface, we do a technique that we call a gravel pack. So when we do a gravel pack, we use a tool that we call a crossover tool. So in this case, I have taken a piece of pipe and I have cut some slots in it, which would represent a gravel pack screen. And then above the gravel pack screen, there would be a crossover tool. The crossover tool is a device which allows you to pump down through the inside, and that is illustrated by this green. So we can pump down through the inside of the green, and it will exit down below these seals, the seal assembly. Okay, and then you can take returns back up the inside of the screen, which is the red, and they will exit above these elastomeric elements that would be sealed off in a seal bore. So the way this is run, so you would have this perforated, and you run this gravel pack screen inside the well bore to where this screen would be across the zone that you're going to produce from, and then this allows us This is a seal bore in which these seals would be sealed off in this seal bore. So we would pump this gravel pack sand slurry down through the inside. It will exit below those seals on the outside and create a sand barrier between the ID of the casing and the OD of that gravel pack screen to serve as a filter to keep the formation sand from flowing through the wellbore and producing out. Any sand produced creates a problem. So this is a way that we use a technique in order to keep formation sand from being produced, getting in all the surface facilities as well as eroding parts of your wellbore. So I hope this video has been helpful to describe how a wellbore is somewhat drilled and completed, and I thought this would be helpful to describe it in a way using a model.